Hi everyone, welcome to lecture number 30, which is Inorder Traversal. Inorder Traversal using an iterative approach. Okay. If you haven't seen my video regarding the recursion, please make sure to see that so that you'll get a basic understanding of how recursion works when we are going through the Inorder Traversal. Okay, first let's see how an Inorder Traversal looks like. So let me mark my notes. 1, 2, 3, 4, 5, 6 and 7. Okay, so this is your root and this is my result array. Okay, so let me start with the root. We won't print our root, we'll go to the left, then we'll take our 4, then there is nothing, right? So we'll come back, which is 2, and we'll go to the right, which is 5, and we'll come back, we'll print our root, then we'll go to the right, we won't print it, we'll go to the left, 6, and we'll next go to the root 3 here, and next we'll go to the 7, right? So this is your Inorder Traversal. So let's see how we can, like, if you haven't seen my recursive video, please make sure to see that. I've posted it. So now let's see how an iterative approach works. It's a little bit tricky, so let me redraw the diagram again. So which is 1, 2, 3, 4, 5, 6 and 7. So this is my root. So there is a use of stack which we need to solve this problem. If you don't know about stack, I've discussed in my previous video a little bit about stacks. You can refer there. I think it is pre-order traversal using an iterative approach. You can see that. Okay, so now this is a root, so this is an empty array. Now you'll have something called a variable, new variable, current node, which will point to root. Okay, so what will be my first condition? I won't print my root, I'll never print my root. I'll have a stack. Whenever I face a new node, I'll add this new node to the stack. 1. If your current node is not equals to nil, then simply add to stack and move towards your left. Okay, so to move towards your left, what you need to do, you need to make your, so this is your current node, right? I'll make it as current node. You need to move to your left, so what you'll make, you'll simply make current node will be your current node dot left. It's that simple, right? So you'll move to the left, so this will be your current node. You can simply cancel it. At first it is root and now it becomes 2, right? And you will do the same again. Yeah, it's a 2, so you have, it's not equals to nil. You'll add this value and it'll move to the left, and now you will mark 4, and this is your current node, and then you'll try to move to the left. You have added it to the stack, so this is changed to 4. So now your left is nil. Okay, so what if it's an else case, right? What you should do, if your value is nil, that means you need to pop out this value, right? You need to pop this value out and add to the result array. Pop, add to result, and you need to move towards right. You have traversed all the left, you have popped this element, you need to traverse its right? So that you need to do here. So first pop the result out, which is 4. You are making, this is the top node, right? So you are popping it. So now let me make a result array. This is your result array. Let's make it 4. You are popping the value out, and now you need to move to the right of this 4. That means your current node will become again nil. So this is your current node, which is again a nil. So what you need to do, you need to pop a new value again, and you need to add it to your result array 2, and your current node became your 2 again. So whether it has a right or not, yes, it has a right, so you'll move towards your right, and you'll simply add it to this stack, which is 5. Again you go to the left, which is nil, right? So you'll pop this value out. This became your 5, the current node previously. You need to pop your value out, so which became nil, and you marked it 5. 5 again came here. then you need to add 5 here, right? After it, do we have anything? No. We again reached what value? This value 2. No, there is no 2 value here. 5 have popped out, we have added to our list, and we are moving towards right. We are getting nil, and then we are going to pop this 1 value. We are popping this 1 value and we are adding it here, and we are moving to the right. So that means our current node is this, and now we are going to add a new thing here, which is 3, which is an empty left, right? So we'll move to the left. 3 will become, again we'll have 6 here. Again you'll repeat the same process. 6, there is no left. That means you'll pop this value. You'll add this value here, and you'll go up, right? You'll get your 3 value, then you'll add your 3, and you'll come back here 7, which is 7. That's it, right? So okay, so there will be a little bit of confusion here when you should break your loop, right? So this will be an entirely like a true loop. So you'll keep a for, and you loop until something condition which breaks this entire loop should be present in the code, right? So that will place it in else. Why? Because when nodes are empty, that means our stack. If our stack is empty, then you can break it. That's it, right? So simply you can add your condition, because you're popping out the top value. If there is no nodes in the stack, then what you'll get by popping it out? Nothing, right? So in the same way, here we'll add a condition. If length of stack or nodes, which it's your wish to keep, if length of nodes is equals to 0, then you can simply break the loop, and that's it. So let's jump into our coding session. So let's see how we can code for this particular Inorder Traversal using iterative approach. So initially, as I said, you'll maintain a current node which points to bt.root, which is root of this particular binary tree. Then you'll initialize a nodes array, which is of star node. You loop until you are infinite times, so you need to have a break condition, which is here. So let's say, what if current node is not equals to null? Then you should add, that means append, like it's a stack, right? So you need to append to this nodes, and you need to move towards your left. What if it's nil? So that means if length of nodes is not equals to 0, then you need to break. If that's not equals to 0, then you need to pop out the top node. From that, after that, you need, you are only taking the node. There is no something like dot pop or like array of indexing -1 like that in Go. So this will give you the top node, and here you need to modify your stack in order to support that stack properties in Go. And then after that, you need to print the top value. And now current node you need to move to the popped out node right side, right? You have traversed the entire left, then the next work is you need to traverse your right. That's it. It's that simple. Got any doubts or questions? Drop them in the comments and I'll do my best to answer them. Don't forget to like the video and subscribe to the channel if you enjoyed it. Thanks for watching, and I'll see you in the next lecture. Until then, bye bye.